Since the Industrial Revolution, CO2 concentration in air has increased by 50%. It has been never so high in last 800,000 years. That is also being linked with global climate change. Industrial plants and vehicular traffic are two major sources of CO2. While we have a relatively well-defined mechanism to capture CO2 directly from plants, it only caters to half of the problem. So in a complementary approach, my PhD thesis aims to capture CO2 directly from air. Our vision is to set up a plant anywhere on planet. And before we realize our vision, there are many challenges. Can we develop materials that can capture high amounts of CO2 from air? Do we have a practical system for that? Can we make something useful out of it? And finally, what is the cost of capturing CO2 and making something useful out of it? To answer our first question, we looked at different materials, and through a systematic molecular engineering, we enhanced their performance for CO2 capture from air. Just 20 pounds of our material is enough to capture CO2 from a large auditorium like this. But just the high capacity is not enough, their stability is also important. Something that works great in dry Arizona may not work at all in humid Florida. So with this and many other factors, we optimized our material for high capacity, faster capture, and high stability. Now, to capture 1 kg of CO2 on a practical scale, we have to process 77,000 gallons of air. An appropriate system for that is porous substrates similar to catalytic converters in our car. But the issue is these substrates by themselves do not capture a lot of CO2. So an important development area here is how do we interface our materials with these porous substrates. Understanding what happens on the surface level, we successfully engineered our materials on these porous substrates and demonstrated that their performance can be enhanced 100 times. Now that we have materials, we also have a process. Now we are looking into how can we convert this CO2 into a bio-based plastic. And our preliminary economic analysis indicates that our process can be very, very competitive to existing technology. Finally, the message that I want to leave all of you with is fight against climate change is real. It's a tough one, but if you're open, if you're focused, and if you're innovative, we can win this fight in a very sustainable way. Thank you.